In modern cosmology, there is a single number that is causing the most brilliant minds on the planet to have sleepless nights. Imagine, we look at the same sky, using the most sophisticated tools humanity has ever built, and ask one single question: how fast is the universe expanding? But reality returns to us two different answers. The discrepancy between them is only a few units, a number so small that you might consider it a routine calculation error. But in precision physics, those few units are not a minor mistake. They are a disaster. Because if that discrepancy is real, it will collapse the entire edifice of knowledge that we have painstakingly built over the course of a century. It invalidates the age of the universe. It distorts the way galaxies form, and it poses a terrifying question about the nature of dark matter, dark energy, and the very way that space-time operates. For decades, we have had a magnificent map of reality. It is called the Standard Model. It explains everything from the echo of the Big Bang to the distribution of billions of galaxies. We were once complacent that we had nearly touched the blueprint of creation, but when James Webb began its operations, the expectation for a final answer vanished. The crack that had existed for so long did not disappear. On the contrary, under the lens of this $10 billion super telescope, that crack appeared clearer, deeper, and more threatening. This is not just a story of dry measurements or distant stars. This is the moment when human science begins to doubt its own most successful picture. Not because we are weak, but because new data from James Webb is forcing us to admit a harsh truth. The universe is not just growing. It is becoming more incomprehensible than anything we ever dared to imagine. To understand why James Webb's data is so shocking, we have to go back to a time when everything was still perfect. For nearly the past 30 years, the astronomical community has operated based on a grand design called the Standard Model of Cosmology. Imagine the universe like a recipe, preordained from the moment of inception, starting from an earth-shattering explosion, the Big Bang. From there, space expanded, matter cooled, and structures began to form. In this model, everything we see from tiny dust particles to supergalaxies actually accounts for a mere 5% of the universe. The rest, that is darkness. It is dark matter, the invisible glue that keeps galaxies from being flung out into space. And dark energy, the phantom force that is silently tearing the universe apart at an ever-accelerating rate. This model is not a vague hypothesis. It is a steel framework that has helped humanity explain almost everything. It helps us accurately calculate the age of the universe as 13.8 billion years. It perfectly predicts how galaxies are distributed on a scale of billions of light years. In the eyes of the international scientific community, this is the most complete map of reality that humanity has ever possessed. A sense of security enveloped research institutes. We understood the rules of the game. We had the answer to the riddle of creation. Many believed that all that remained was to refine a few decimal places. We were very close to the end of the journey of understanding the universe. But there is a harsh truth in science. A map is only truly powerful until reality begins to mismatch it. And in cosmology, the first thing that began to deviate was a number that seemed fundamental: the Hubble constant. In the 1920s, astronomer Edwin Hubble realized a shocking truth. Galaxies are not standing still. We are in a universe that is constantly expanding. A strange law was established. The further away they are from us, the faster the galaxies are receding. And the Hubble constant is the precise measure for that rhythm. But why should you care about the universe expanding faster or slower by a few units? Because this number is not just a statistic. It is the key that shapes everything we know about reality. If the universe expands faster, it means it is younger than we thought. If it expands slower, it is older. This number determines the distance between stars, how galaxies are born, and finally, it decides how our universe will end. Collapsing back into itself, or vanishing forever into a cold void. And this is where the horror of mathematics begins. The scientific world is currently divided into two opposing camps. One side, based on data from the early dawn of the universe, asserts that the number is approximately 67. The other side, when looking at stars closer to us, insists it must be 73. From the outside, the difference between 67 and 73 is only about 9%, a margin of error that might seem excusable in everyday life. But in precision cosmology, that 9% is an unfillable abyss. It is like positioning an airplane landing from thousands of miles away. Just a few units of deviation in the calculation, and the plane will not land on the runway, but will crash into a mountain somewhere due to a massive positional error. The problem does not lie in our lack of ability to measure. The problem lies in the fact we have measured extremely carefully 2 leading research groups using the most advanced technologies and the most massive datasets, yet the results never agree at a single point. They use data from the cosmic microwave background radiation, the most ancient light, the echo remaining from the Big Bang. Combined with the standard model, they calculate the expansion rate of the universe today. And the number they found is 67. This is a solid number, reinforced by extremely detailed data from the Planck satellite. It represents theoretical stability. Instead of predicting from the past, astronomers decided to measure directly right here and right now. They constructed what is called the cosmic distance ladder. They look at Cepheid variable stars, objects that pulse with a regular rhythm like precise clocks. They look at Type Ia supernovae explosions, brilliant light milestones visible from billions of light years away. By measuring the actual distances between neighbouring galaxies, the research team led by Nobel laureate Adam Riess provided the answer 73. Let's pause for a moment to feel this absurdity. The same universe, the same history, but if you look at the infant photo, the universe is expanding slower, whereas if you look at mature reality, it is rushing away faster. This is not an emotional argument. This is a confrontation between the most brilliant minds working with absolute caution. Both sides have checked and rechecked thousands of times. Both sides possess indisputable data. The more precisely we measure, the more that gap refuses to vanish. It is no longer an error. It is a rigid and cruel truth. In the world of science, when 2 precise measurements do not match, it means only one thing. The universe is trying to tell us that we have misunderstood something extremely fundamental, and that is when all eyes turn toward James Webb. Humanity needs an arbitrator. Someone who can see clearer than anyone else to declare who is right, who is wrong. Or are both sides seeing a truth even more terrifying than that? In December 2021, a $10 billion entity was launched into space, the James Webb Space Telescope. In the scientific community, Webb is not just a tool. It was expected to be a supreme arbitrator, a brilliant detective that could put an end to the controversy over the Hubble constant that had lasted for decades. Why did we believe in James Webb so much? Because there was a reasonable suspicion that perhaps the legendary Hubble telescope was wrong. For years, it was thought that Hubble might have been deceived by cosmic dust or the phenomenon of crowding, when light from too many stars is blended together, distorting distance measurements. But James Webb is different. With its extremely powerful infrared eyes, it can see through the densest dust clouds. With its giant mirror, it can resolve individual stars at distances of millions of light years with unprecedented accuracy. The plan at that time was very simple. Let Webb look back at what Hubble had seen. If Webb corrected the number 73 back towards 67, then congratulations to humanity. It was just a technical error. The crisis would be over. But reality always has a way of leaving us stunned. When the first data from James Webb was analysed by Adam Riess's research team, a chilling truth appeared on the screen. James Webb did not negate Hubble at all. On the contrary, it confirmed that Hubble was absolutely correct. The measurement results from Webb still stood firm at 73. The telescope that was expected to extinguish the flames of controversy has now, inadvertently, added fuel to them. Because if James Webb is right, if the Hubble constant truly is 73, then we must face a prospect even more terrifying than mechanical error, that our model of reality has completely collapsed. But science never accepts defeat easily. Before declaring the standard model dead, another group of explorers stood up challenging the results of both Webb and Hubble. Leading this skeptical faction is astronomer Wendy Friedman. Instead of trusting the already controversial Cepheid variable stars, she and her colleagues chose a different path: the tip of the red giant branch. This is another yardstick, another lighthouse in the universe. And strangely, when using this method, the returned number is neither 73 nor 67. It hovers around 69 to 70. Look at this chaos. One universe, yet we have three answers: 67, 70, and 73. It is like asking three witnesses about the same accident, and each tells a different story about the same event. This turns the Hubble constant crisis into a foggy case. The more data we have, the murkier the picture becomes. Many would think this is a failure of science, but in reality, this is the most exciting moment. Science is not a straight line from hypothesis to truth. It is a process of continuous self-doubt. For the first time in decades, the data is strong enough to force humanity's most successful model to justify itself from scratch. We are no longer arguing over which telescope is better, but rather, are we seeing something that human intellect does not yet have a name for? If both numbers 67 and 73 are correct within their respective ranges, then a cruel truth emerges. The bridge between our past and present has broken. This means that the standard model, the steel framework humanity uses to understand the universe, is missing its most vital piece. A certain component in the time machine has been forgotten. Theoretical physicists began searching through the shadows of equations, and they found a potential suspect: early dark energy. Imagine, immediately after the Big Bang, a strange type of energy appeared. It is not the dark energy we know today. It existed for only a brief moment, creating a powerful kick, accelerating the expansion of the early universe before suddenly vanishing into the void. If this kick is real, it would explain why current measurements yield a figure of 73 faster than expected. But this is the scariest part. If we accept the existence of early dark energy, we must also accept that the universe is not as stable as we thought. Dark energy is not an immutable constant. It can change. It can evolve. Could it be that space-time behaved differently in the early stages? Could the universe have had a fiery and chaotic first chapter that the current standard model has only read as a brief summary? Perhaps gravity is not the same everywhere in the universe. There could be a new type of dark matter particle that we have yet to name. Or, more crazily, perhaps we are living in a universe with more spatial dimensions than the human eye can perceive. When scientists directed Webb's golden eyes toward the deepest reaches of space, where we can see the universe when it was only a few 100 million years old, they expected to see baby galaxies, chaotic, small, faint, and simple clouds of gas. But reality once again slapped the most confident hypotheses. Webb has sent back images of things that the astronomical community calls by a provocative name universe breakers. James Webb found massive, colossal galaxies with masses comparable to our Milky Way, yet they existed at a time only 500 million years after the Big Bang. Pause for a moment to feel this absurdity. It is like exploring a prehistoric cave, only to suddenly find a precision-running atomic clock lying next to stone tools. According to every model we have, mature and heavy galaxies like these should take billions of years to form. They could not have had enough time to grow up so fast in a newly born universe. This puts NASA and the scientific community in a dilemma. Have we completely misunderstood the growth rate of stars? Or did the early universe have some mysterious acceleration engine that humanity has never known? But the story has another interesting twist. Among those infrared images, Webb discovered a series of little red dots. Initially, they looked like massive galaxies containing billions of old stars. But deeper studies began to reveal another possibility. It could be impersonating light. Perhaps these galaxies are not that heavy at all. Instead, their hearts contain supermassive black holes that are frantically devouring matter. It is the ghostly light from these black holes that has deceived us, making the galaxies appear brighter, larger, and more mature than they actually are. But even if that is the truth, it still leads to an equally terrifying question. How did those giant black holes appear so early? James Webb does not necessarily have to kill the standard model. but it is forcing us to admit a harsh truth. We cannot keep saying that everything is fine. In our old script, the early universe was a place of total chaos. The first galaxies were thought to be geometric monstrosities. They were distorted, had no clear shape, and required billions of years of collisions to create orderly structures like spirals or disks. We called that the infancy stage of space, a period when everything was rudimentary. But James Webb looked into that dawn and saw a completely different reality. It found galaxies with perfect disk structures, galaxies that were rotating in an order fashion from the time the universe was only 3% of its current age. It is more diverse, matures faster, and seemingly it knew how to become complex right from the starting line. This is pushing the astronomical community into a large-scale review. Were stars born at a rate 10 times faster than what we had previously calculated? Did dark matter act more actively to gather gas into orderly structures in the blink of an eye? This is exactly when we must admit, James Webb does not bring answers, it brings humility. It forces us to admit that, for the past century, we may have misread the rhythm of time. We once thought we held the diary of the universe, but as it turns out, James Webb has just flipped to a new page and shown us. The first chapters are more brilliant and complex than anything we ever dared to write down. And if this complexity is real, if order was present that early, then what truly are the foundations of the entire picture, the things we call dark matter and dark energy? We are touching the core of the mystery. In modern cosmology, those strings are precisely dark matter, the invisible glue that keeps galaxies from flying apart. And the artist controlling the tempo of the performance is dark energy, the phantom force that is forcing space to expand. The astonishing thing is, humanity's best model of reality depends entirely on two components that we have never seen directly. We only know they exist because we see what they do to luminous matter. This means that our current so-called understanding of the universe is, in fact, still just a description of operations. We know how the universe functions, but we have never truly understood the nature of the things that are operating it. 95% of the universe remains an absolute shadow to human intellect. And this is when the real unease begins. If what James Webb is seeing is real a discrepancy in the expansion rate, galaxies growing unusually fast, then perhaps these ghosts are not behaving as we thought. What would happen if dark matter is not stationary, but is evolving? What would happen if dark energy is not an eternal constant, but is changing its strength over time? If the foundation of the picture is shifting, then our entire tower of knowledge will shift along with it. What we call laws of physics might only be temporary rules within a certain chapter of cosmic history. The beauty, and also the greatest fear of modern cosmology, lies at this very point. We have known so much, have gone so far, but the most decisive part of the universe, the thing that holds the destiny of every star and every atom in your body, is still a pitch-black region. We are trying to solve a problem where 95% of the data still lies in the hands of a hidden entity. Some people look at the cracks that James Webb has just revealed and call it a collapse. They believe that the castle of knowledge built by humanity over the past century is merely a massive misconception. But in the world of those who seek the truth, the reality is exactly the opposite. Science is never at its strongest when it claims to know everything. Science is at its strongest at the very moment it dares to admit we were wrong. Look back at history. There was a time when humans believed that Earth was the center of all things. When that hypothesis collapsed, we did not lose the universe, we found the solar system. There was a time when we believed that the Milky Way was the final boundary of reality. But when Edwin Hubble shattered that belief a century ago, space did not shrink. It expanded billions of times over. Every time a theoretical model is shaken, it is not the sound of a failing structure collapsing, it is the sound of a cocoon shell breaking, preparing for a greater, deeper emergence of human knowledge. A good standard model is not one that is never questioned. Rather, it is a model robust enough to survive the harshest tests, or brave enough to evolve itself into something better. Hubble tension, this uncomfortable discrepancy, is not a period, it is a hyphen. It forces us to step out of the comfort zone of old equations. It compels us to re-ask questions that we once thought had absolute answers. The universe does not change its laws just to make things difficult for humans. It is simply that we are gradually maturing to see the more complex layers of meaning behind the surface. Science does not fail when it discovers a flaw. It only fails when it intentionally ignores that flaw. And James Webb, with all the trouble it brings, is precisely the greatest gift the universe has sent to human curiosity. A new problem that we never even knew we needed to solve. James Webb may be the one who pointed out the crack and opened the door to a new frontier, but to truly explore that frontier, we need a more specialized army of detectives. Detectives who not only look deep, but must also look wide, meticulously measuring every nook and cranny to deliver the final judgment for reality. This revolution is not alone. Right now, an array of next-generation space hardware is being deployed in orbit, ready to join forces with James Webb to decode the greatest secrets we have ever faced. First is Euclid, the detective from the European Space Agency. If James Webb is a microscope peering into the microscopic details of the early universe, then Euclid is a giant wide-angle camera. Its mission? Mapping the large-scale structure of the universe across 10 billion years of history. Euclid is hunting for the hidden entity behind all this trouble, dark energy. By observing how billions of galaxies are distorted and distributed, Euclid will tell us whether dark energy is an immutable constant, or if it is truly changing and playing with our understanding of expansion. And not far behind is Nancy Grace Roman, NASA's next hope. This is a telescope designed to do what both Hubble and Webb would find difficult to do alone: observe billions of galaxies in a single frame with ultra-high resolution. Roman will be the great surveyor, checking the accuracy of every distance measurement. It will re-examine every rung of the Hubble constant ladder, searching to see if there is any subtle error lurking within variable stars or supernova explosions. It will be the one to provide the decisive voice to see who truly holds the truth between 67 and 73. Meanwhile, the detective Gaia is still working silently, measuring the positions and movements of more than 1 billion stars with unbelievable precision. This data is the foundation for recalibrating humanity's entire cosmic yardstick, a rigorous preparation ensuring we are no longer deceived by any illusions of the cosmos. What does this mean? It means we are not merely revisiting an old debate from the past. We are living in the midst of a judgment unfolding in real time. From the Hubble constant tension and the absurd massive galaxies to the very nature of dark energy, everything is being pushed to its ultimate limit. In just a few years, as these detectives join forces with James Webb, humanity will have to issue a new manifesto about the universe. We are preparing the sharpest eyes to peer into the deepest darkness. The game is never over. In fact, it has only just entered its most decisive phase. After all, the Hubble Tension, or the absurd massive galaxies that James Webb found, are actually teaching us a lesson in humility. We are only a tiny species on a pale blue dot, orbiting an ordinary star at the edge of an unremarkable galaxy. Yet, we are ambitious enough to build machines that look back billions of years in time, attempting to redraw the map of all reality. And when that map no longer matches the land where we stand, that is not a time for fear. Because when the map is wrong, it means the land out there is much vaster, stranger, and far more exciting than anything we ever imagined. The universe has no obligation to be understandable to us. It does not operate to satisfy the equations humans write on paper. It has its own pulse, its own hidden chapters of history of which we have perhaps only just finished reading the blurb on the back cover of the book. Perhaps the universe is not contradictory at all. It is simply that we are not yet mature enough to fully understand its language. What awaits us ahead in the upcoming data from James Webb, Euclid, or Roman is not the collapse of science. Instead, it is a version of reality that is more brilliant, more profound, and more terrifying. Because the most wonderful part of this journey is not finding the final answer. It is the realization that the most incredible thing about the universe is that we are capable of understanding a part of it. Thank you for joining Dark Orbit on this journey to decode these secrets. Don't forget to hit subscribe so you don't miss the next Cosmic Profiles. Because out there, there are still many things that have yet to be told.